Hey guys, we are at 3.9 polyhedra. It's pretty straightforward stuff. You should have read this in the book already. I'm just going to take you through the basics. Polyhedron is a three-dimensional figure. So you've got polygon that's two-dimensional. Polyhedron is three-dimensional, and this is just the plural. So you have one polyhedron and you have two polyhedra. Anyway, these are the regular polyhedra. Regular is just when you've got a shape that has all equal sides and all equal angles. There are only 5 three-dimensional shapes that can be made using one type of regular polygon. So this is our equilateral triangle, and I can make this shape, which has 4 sides, and it's called a tetrahedron. If I make 2 pyramids with equilateral triangles and join them like this, I wind up with this next regular polyhedron, and this one is called an octahedron. Okay, so this has 4 sides, so it's tetrahedron. Tetra means 4, and octa is 8, and that's an octahedron. And in between this is our 6-sided shape that we're familiar with from gaming dice, and this is called a hexahedron. So it can be confusing because you think of hexagon, but hexahedron has 6 regular polygons, which are squares, and that's our third one. Then another one, a little bit more complicated, is a 20-sided shape, all made out of equilateral triangles. That's an icosahedron, again about 20 sides. You could call it a 20-hedron if you wanted to. And then we've got pentagons making up a dodecahedron, again counting the 12 sides. This has 12 faces. Actually, they should be called faces, not sides, but you'll know what I mean, and I'll know what you mean if you call them sides. But these 12 faces make our dodecahedron. Okay, so these are the 5 solids that are made using one shape, one regular polygon. They're named the Platonic solids because Plato wrote a sort of theory of atoms based around these shapes, and they've been drawn and commented on since the times of ancient Greeks. Anyway, one of the things that you want to think about is what happens if you pick any point, any vertex of a polyhedron, and then open up the shape at that. So I'm going to do that using these plastic figures that you guys are going to get to play with. But let's just pick this corner here, and if I open this shape up like this and lay it flat, you can see that now after I've laid it flat, that this is our gap right here, all the way around here when we open this up. These are all 60-degree angles, so you can see that this is a 180-degree gap, and that's actually called the defect angle. All right. These, like I said, 60-degree angles, when laid flat from this one vertex, this is the defect angle. Okay, and so one of the things you're going to do in your homework is you're going to add up those defect angles. So this defect angle for my tetrahedron is 180 degrees. Okay, what's the defect angle going to be if I open up one corner of this? My hexahedron, my cube, my die, whatever you want to call it. If I just look at this corner here and I bust out the other ones. Okay, so here's my one vertex. If I open this up and lay it flat, now you can see that with 4 squares, my defect angle is going to be, wait for it, 90 degrees. All right, so that'll be a 90-degree defect angle. All right, so now I can take and look at this one. This is our octahedron. All right, again, pick one corner, one vertex, open that up. I bust these out of here. There's the one vertex. If I open this up, okay, now if these are all 60 degrees, this particular vertex, this particular defect angle is going to be 120 degrees. Okay, if you just do the math, there's our 60, 60, 60, that makes 180. Take away another 60, and now it's the defect angle is 120. Okay, our icosahedron gets a little bit more complicated. All right, if I break this open, now I've got 5 of these. making one corner like this. Right, so when I open that up, now I've got my defect angle here. I gotta cover up my 120. That defect angle's down to just 60 degrees. Okay. And finally, I'll let you think about this one. This is maybe more complicated, but I think you got the routine. There's only 3 pentagons at this corner, so I want you to tell me what is the defect angle of this dodecahedron when you open up those 3 pentagons. So you might need to look up in your chart the angles of a pentagon, and that's your challenge. Okay? Okay, so just to review, regular polyhedron are those 5 types that I've shown you where they're made of just one type of regular polygon. You can only make the regular platonic solids, the regular polyhedron, using equilateral triangles, squares, or pentagons, just those 3 types. So then take a look at this thing. All right, this is a shape that is made out of only 2 types of regular polygons. There's a square, there's an equilateral triangle. Each vertex is the same. It's got 2 equilateral triangles, 2 squares. Every time I pick a vertex, you'll see 2 equilateral triangles, 2 squares. All right. This is called a semi-regular polyhedron. It has 2 types of regular polygons, and there are a bunch that are made like this, and in class we'll make a few more. But if you look at this, there's an example of a semi-regular polyhedron. Okay, so that's what you need to know.